or pre-calculus. And what happened was, you would get to a part where you had all these trig rules, like I threw down on Tuesday. And then it would say, something real quaint like verify. They would give you some trigonometric vomit next equals something. So they said you can't multiply things to both sides. You have to actually change the one side and change, and so on. And you hated those, right? Because it's like, I don't even know what direction to go. It's like all over the place. Well, we're now to the point where I give you the left-hand side, you got to figure out what the right-hand side should even be. Here's what I mean by that. You're going to start with a trigonometric mess. You have to use your rules and everything to get it to a place where you can actually integrate it. We're going to start nice and simple. Here I have the integral of cosine x times sine to the fifth x dx. Please keep in mind, sine to the fifth x is the same thing as sine of x with parentheses with the fifth power on the outside. The whole thing is raised to the fifth power, meaning the range itself is raised to the fifth power. I'm going to go ahead and do a substitution. I need to think ahead, and this is where we're going to be going with this. We need to think ahead. If I let u equal sine of x, what's its derivative? Cosine, which is there. So I need to kind of look for that part of the u substitution that's going to be there, that I'm going to be able to eliminate it with. So if I do a substitution and let u be sine of x, that means that du is cosine x dx, which beautifully works out for the substitution. I'm looking for this piece. I kind of have to see it ahead of time. And now that I can see that I can make that simple transformation, this nicely makes this u to the fifth power du. You finish writing that down, turn to someone and just make sure that they understand what's going on. Just kind of do that point and talk thing that she does. Yeah.
I know, she'll tell me.
I'll tell you.
The first thing she says.
He's not going to move, he just wants to know.
Well, it's not just for me. It's her.
Yes, you are. You're gonna lose
Did you ever get that tattoo?
No, but I got new ones. I couldn't. It was
Right.
too small. Well, my arm was too small for that much
In this
detail.
case, I have the integral of tangent x times
I'll show you my
secant to the
ones later.
seventh x dx. Now I want to do the think ahead thing. What if I let u equal secant x? What's the derivative of secant?
Secant tan.
It's secant tangent. Now, I only have tangent, it looks like. What I'm going to do is I'm going to rewrite it.
What?
It's the same thing, right?
Yeah.
So we have to get a little creative. Math students hate getting creative. But we can see ahead of time that I'm going to have that derivative before I even do the substitution. It's right there. So I kind of did what I saved off part of the function so that I could use that antiderivative, or that derivative when I'm doing my substitution. I saved off that secant. I made it look familiar to me, so I was a little bit more comfortable doing the substitution. Now, when I transform it, very nicely, all those extra pieces drop out.